Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers. Here is another video in calculus. I hope that it will help you enhance your skills in mathematics. This is about graphs of functions. Now, if you want to anticipate the answers to the exercises here, you may do so by pausing the video. So, here is the first exercise. Suppose the graph of f is given. Write equations for the graphs that are obtained from the graph of f as follows. So shift 4 units upward, shift 5 units downward, shift 2 units to the right, shift 1 unit to the left, reflect about the x-axis, reflect about the y-axis, stretch vertically by a factor of 4, shrink vertically by a factor of 6. So if the graph of the given function is y equals f of x, then in part A, shifting 4 units upward means you have to add 4 units to y equals f of x. Therefore, the equation is y equals f of x plus 4. Then shift 5 units downward, so y equals f of x minus 5. Shift 2 units to the right, so then the function becomes y equals f of quantity x minus 2. If you shift it 2 units to the right, so it should be y equals f of quantity x minus 2. So that if you shift it to the right 2 units, then the value would be the original. Shift 1 unit to the left, so the equation of the function becomes y equals f of x plus 1. And from the preceding exercises, especially on graphs, I hope that you will learn techniques on how to write uh, equations of functions based on these recommendations or this procedure. Reflect about the x-axis. So if the graph is initially above the x-axis, then if we reflect it about the x-axis, the ordinates would be negative. Therefore, reflecting it about the x-axis, the equation would become y equals negative of f of x. Then if we reflect it about the y-axis, remember the graphs of uh, add functions, they are uh, reflections about the y-axis. So y equals f of negative x. Stretch vertically by a factor of 4. So when we stretch the graph vertically by a factor of 4, it means that we have to multiply 4 to f of x. So y equals 4 times f of x. And if we shrink the graph vertically by a factor of 6, then it is y equals 1/6 of f of x. So that's it for that exercise. Now we proceed to the next one. Explain how the following graphs are obtained from the graph of y equals f of x. So we base the answer explanations from our experience with this. So y equals 5 times f of x means we have to stretch the graph vertically by a factor of 5. So stretching the graph by a factor of 5. Stretching vertically by a factor of 5. Y equals f of x minus 5, just like here. So that means we have to shift it 5 units to the right. The graph should be shifted 5 units to the graph, or shifting 5 units to the right. y equals negative f of x, so it is reflecting about the x-axis just like here. So reflecting about the uh, x-axis. So reflecting about the x-axis just like here. Y equals negative of 5 times f of x. That means we have to reflect the graph of part A after stretching it vertically by a factor of 5 about the x-axis. So reflecting about the x-axis, the graph of y equals 5 times f of x. Then f of 5x, we have to shrink horizontally by a factor of 5. So the graph should be, uh, we have to shrink the graph horizontally by a factor of 5. So shrinking horizontally by a factor of 5. So if originally it is 10 units, the graph is 10 units wide, then shrinking it by a factor of 5, it will become 2 units wide. 10 divided by 5 is 2. So y equals 5 times f of x minus 3. So we have to shift the graph vertically 3 units downward. Graph of y equals 5 of f of x. So shifting, we have to shifting 3 units downward, the graph of y equals 5 times f of x. Now for the next exercise, the graph of y equals f of x is given. Match each equation with its graph and give reasons for your choices. So these exercises are really conceptual in nature. It will help you or even me uh, explain graphs in the future and even functions where we have to imagine. So y equals f of x minus 4. We have to match these functions with the given graphs here. So this is the original graph of the function f of x. Then these are the different graphs. Graph 1, graph number 2, graph number 3, graph number 4, and this is graph number 5. And to answer this, we need to have these experiences here in order to answer this question. So y equals f of x minus 4. So meaning to say we have to shift the graph of f 4 units to the right. So this is the original graph. Then shifting it 4 units to the right, which is here. This is this is 0, 1, 2, 3, 4. So it is now here, and it ends at 3. So it now ends at 7 for the original graph. So therefore, this y equals f of x minus 4 is after we shift the original graph 4 units to the right, and that is graph 3. So the answer, we match this with graph number 3. Then y equals f of x plus 3. That means we have to shift 3 units upward the original graph. This is the original graph. Then we have to shift it vertically 3 units upward. So for instance, for this ordinate here, this is 1. Now that we shift it vertically upward, it should be 4. So right, 1 plus 3 is 4. So therefore, y equals f of x plus 3 matches with graph number 1. So graph 1. Y equals 1/3 of f of x. We have to shrink the original graph by a factor of 3. So this is the graph. 1/3 of f of x. Originally, if the ordinate here is 1, then 1/3 of f of x, it becomes 1/3. If the ordinate here is 3 at the peak, then 1/3 of 3 is 1. So therefore, part C is y equals 1/3 of f of x is matching with graph number 4. It is we have to shrink it vertically by a factor of 3. So this is it, graph 4. Then y equals negative of f of x plus 4. If we concentrate on f of x plus 4, it means that it is shifted horizontally 4 units to the left, just like here, 4 units leftward, shifting 2 units to the left, so f of x plus 1. So don't mind the sign first. F of y equals f of x plus 4 means that we have to shift this graph here 4 units to the left. So this one will become negative 4. So it is here, supposedly. That is the graph of y equals f of x plus 4. Then, because of this negative sign, it means that we have to reflect it about the x-axis. So imagine that this graph is shifted 4 units to the left, which is now here, this one. Then, this graph here. Then after that, we reflect it about the x-axis. After reflecting about the x-axis, this is now the graph. So therefore, letter D matches with graph number 5. So graph 5 is the answer. Then, so that's y equals f of x plus 4. Then, of course, this is the remaining graph. So no doubt, it is this graph here, graph 2. But let me explain it first. Y equals f of x plus 6 means this original graph here is being shifted 6 units to the left. So it will now be here. Then after shifting it 2 units to the left, it is stretched vertically by a factor of 2. So stretching it vertically by a factor of 2 from negative 1, from positive 1 rather, this ordinate here. So it becomes 2. And the height from 3 times 2. So that's why the peak here is 6. So therefore, this graph, this y equals 2 times f of x plus 6 matches with graph number 2. So this is supposedly 2 times f of x, y equals 2 times f of x, then shifting it to the left 6 units, this is the graph now. So that's why it is graph number 2. So that's it for this video. I hope that you learned something new in calculus. If it is new, because for me it's also new on my part.